At this very moment, far beyond the familiar warmth of our solar system, where the sun no longer dominates the sky and appears only as a faint star among countless others, an aging machine is still alive. Voyager 1 continues its journey through interstellar space, moving farther from Earth than any object humanity has ever created. Built in the 1970s with technology that now seems ancient, it survives on a slowly fading nuclear power source and carries less computing capability than devices we use every day. By all expectations, it should have stopped communicating years ago. Yet it did not. Decades after leaving Earth, Voyager 1 is still sending signals back across unimaginable distances, and the information it returns suggests something unexpected. The region beyond our solar system may be far more active and structured than scientists once imagined. In 1990, engineers made a difficult choice. To preserve energy and extend the mission, Voyager's cameras were permanently shut down. But before losing its vision forever, the spacecraft received one final command: turn around and look back at home. It was not a simple maneuver. The spacecraft was already old and operating in harsh conditions. Components had endured years of extreme temperatures, radiation exposure, and mechanical stress. Rotating the spacecraft carried risk. Still, it obeyed. The image it captured became one of humanity's most famous views, our planet appearing as a tiny point of light suspended in a sunbeam, the pale blue dot. But the image itself contained distortions, scattered light, glare, and optical artifacts. Most were considered normal effects at the time, yet some researchers later reflected on how even these imperfections hinted at the complexity of the environment surrounding the spacecraft. Voyager 1 is not a modern intelligent probe equipped with advanced autonomous systems. It belongs to another technological age. Its hardware is old, its memory extremely limited, and many of its operating principles come from engineering methods developed over half a century ago. That makes its continued survival remarkable. Signals sent from Earth now take more than 20 hours to reach it. The reply requires another journey back. Every exchange with Voyager spans nearly 2 days. And still, it answers. As the mission aged, communication became increasingly difficult. Engineers encountered corrupted telemetry, memory issues, unexpected behavior, and aging systems affected by decades of radiation and extreme cold. Yet amid those challenges, Voyager kept delivering something extraordinary. It began revealing that the space surrounding it was not behaving like the empty void many people imagined. For years, scientists expected the outer boundary of the solar system to be gradual. The influence of the solar wind would slowly weaken, blending smoothly into interstellar space. Instead, when Voyager crossed the heliopause, the outer boundary of the Sun's influence, reality looked very different. Particle densities shifted abruptly. Cosmic radiation levels changed. Plasma conditions transformed. Rather than a soft transition, the edge appeared more like a compressed frontier separating our solar environment from the wider galaxy. Beyond that boundary, Voyager detected oscillations and plasma activity suggesting that interstellar space is not silent or inactive. The medium between stars appears to possess structure. It carries pressure, electrical activity, movement, and organization. The old picture of empty space as a featureless vacuum suddenly looked incomplete. This possibility becomes even more intriguing because Voyager is not merely observing distant stars or planets anymore. It is directly sampling the environment itself. Its measurements raise larger questions. What if the regions between stars contain gradients and flows we do not fully understand? What if interstellar space possesses properties more dynamic than earlier models predicted? The anomalies Voyager reports are subtle. There are no dramatic discoveries or obvious contradictions. Instead, there are persistent irregularities, small deviations that continue appearing. Science often changes this way. Major shifts rarely begin with spectacular events. More often, they begin with tiny mismatches between prediction and observation. Voyager is exploring territory no spacecraft had previously entered. If that environment behaves differently from expectations, then the mission is doing more than exploration. It is marking the place where our understanding may need revision. This gives Voyager a new significance. Originally, it was built to study planets. It transformed our view of Jupiter and Saturn. Now, decades later, it may be revealing something even deeper, that the space between objects is itself part of the mystery. There is also something profoundly moving about the timing. Voyager is slowly losing power. Systems have been turned off. Instruments operate under extreme conditions. Every additional year is borrowed time. Yet as the spacecraft weakens, its discoveries become more important. At the same time, it still carries humanity's message outward. Attached to its side is the Golden Record, a collection of sounds, music, greetings, and images representing life on Earth. So Voyager travels in two directions at once. It sends scientific information back toward humanity while carrying a symbolic message away into the unknown. Perhaps that is why its story feels so powerful. Voyager is no longer simply a spacecraft. It has become a witness. Far beyond the planets, beyond the fading influence of the Sun, Voyager 1 continues moving through a region humanity once imagined as quiet and empty. But the deeper it travels into interstellar space, the more that assumption begins to unravel. For decades, scientists viewed the space between stars as a vast separation zone, mostly vacuum, thin particles, scattered radiation, and little else. It was never expected to be completely empty, but it was often imagined as passive. Voyager's observations tell a different story. After crossing the heliopause, the spacecraft entered a region where the density of interstellar plasma appeared higher than many models predicted. Waves moved through this medium. Disturbances propagated across enormous distances. Space itself seemed less like emptiness and more like an environment. The discovery changed perspective. Instead of drifting through nothing, Voyager appeared to be moving inside a larger galactic system filled with invisible structure. And that raises a profound question. If interstellar space possesses pressure, flow, and organization, then what shapes it? Part of the answer may lie in magnetic fields. Our galaxy is threaded with enormous magnetic structures stretching across vast regions of space. They guide charged particles, influence cosmic radiation, and help shape the movement of plasma between stars. Voyager entered this magnetic environment directly. One of its surprising findings was that the magnetic field beyond the heliopause remained unexpectedly aligned with the one inside the solar boundary. Scientists expected a stronger directional shift. Instead, the transition appeared smoother. That result created new questions about how our solar system interacts with the surrounding galaxy. Rather than existing inside isolation, the Sun may be embedded within a larger magnetic network whose influence extends much farther than once imagined. And Voyager is moving through it. The spacecraft has also become one of humanity's best tools for studying cosmic rays, energetic particles accelerated by violent events such as supernova explosions and stellar activity across the galaxy. Near the heliopause, cosmic ray levels changed dramatically. As the Sun's protective influence weakened, Voyager encountered a different radiation environment. The solar system suddenly appeared less like an isolated island and more like a bubble floating inside a much larger cosmic ocean. That image carries consequences. Because if our heliosphere acts as a shield, then understanding its structure becomes essential for understanding how life survives here. Voyager showed that this shield has edges, pressure zones, and complex boundaries. It is not simply fading sunlight. It is architecture. The farther Voyager travels, the more the solar system looks less like a collection of planets and more like a moving vessel drifting through the galaxy. And that idea changes scale. Our entire planetary system is traveling through interstellar space while carrying its own magnetic bubble around a star. Voyager is now outside that bubble looking back from the other side. No spacecraft has ever done this before. That alone makes its mission extraordinary. But there is another reason Voyager feels almost haunting. It is alone. No repair mission will ever reach it. No astronaut will ever stand beside it. Every signal arriving on Earth left the spacecraft nearly a day earlier. We are always hearing its past. And one day, those signals will stop. Its power source continues fading year by year. Instruments are gradually shut down to preserve what remains. Eventually, there will not be enough energy left. The transmissions will end. Voyager will continue moving, but silently. Even then, its journey will not truly finish. Long after Earth changes, long after civilizations rise and disappear, Voyager will still drift among the stars carrying the golden record. Its message will remain. Sounds of oceans. Human voices. Music. Images. Fragments of a species that once looked upward and decided to send a small machine into the dark. Yet perhaps Voyager's greatest message was never the record attached to its side. Perhaps it was the data. Because the spacecraft keeps reminding us of something unexpected. The universe often becomes stranger the closer we examine it. The edge of the solar system was not what we imagined. Interstellar space was not what we imagined.